Hey, what's up? It's Turpy here, and I paid for access to GPT-3, and I thought I'd go over some of the stuff that I've been messing with in it. And what you see in front of you is some of the more recent completions that I've managed to get from it doing uh, a analogizing task. Um, yeah. So right here, we can see in some of these prompts, if I just highlight one real quick. Um, this is the last prompt that I did while making that specific task, and it's based off of the playground version of the uh, put this in terms a fourth grader would understand. So I took that and I was like, all right, well, can we put it in terms that specific professions would be more um, used to? And I got to the point where eventually um, I was getting it to try and make analogies out of machine learning tasks using language that, like, for example, a politician would. So, to kind of give a short example, these are fairly long, but it starts out the prompt that I gave it to rephrase was this right here. And it starts with machine learning is a branch of artificial intelligence that gives computers the ability to learn without being explicitly programmed. So the translation into politician speak is let's assume you're an election day worker. You are handed a voting machine that has never been used before with instructions to set it up. When you open it, it has already made predictions on the election. It tells you with 95% confidence that the Republican candidate will win the election, right? So it took this phrase and translated it into this phrase, right? Because even though they're about different things, that is analogous to what it was trying to say about machine learning. And this example goes on even further, and it's actually quite interesting. I'll probably post it in the description if anyone's interested. But we'll move on here if you guys just give me a second. So over here we have the playground, the no code solution that OpenAI has come up with, and it's very robust. We have options to pick from different engines to do the different tasks, and it has descriptions of what each engine does task wise, and they all have different levels of efficiency, different state of the art abilities, and different costs per uh, uh, for computation time, essentially, right? Because that's what all of the prices are based off of for the OpenAI API. It is the time to compute your tokens is essentially what they're charging you for. So we have DaVinci, which is, like it says, the most capable model. Um, it can perform any task the other models can, often with even less context. If I'm not mistaken, it does have zero shot abilities that I haven't looked at yet. And for those of you who don't know what that means, zero shot learning essentially means that it can look at a task and perform it without having to sample anything from its uh, from its model, essentially. Well, no, it does it all based off of association, and it doesn't perform any searches internally. Is kind of the best way to analogize that. It probably horrible. If anyone has a better description, please God, let me know. But there's also, we're going to mess with this here, the DaVinci Instruct beta. So it can do like most of it can do what the other DaVinci can do, but it can do it with, again, even less context, right? So we're going to look at the difference between the two different prompts that it'll end up generating here. So what we have set up is a playground that should give us a numbered list of what this Python function is doing, or what this class initialization is doing, right? So what this class method initialization is doing in natural language. So let's just hit generate. As you can see, we have the probability highlighting over here. This is kind of useful for knowing in some way what is affecting what and where and why, and just different things that machine learning has been missing for visualizing different aspects of how the model ended up at a conclusion of some kind, made an inference, right? So this is really cool because I didn't cherry pick this one, we just generated this one, and this is code that I wrote myself for a game in MicroPython. So it says the init function is called when the class is instantiated. The init function creates a new instance of the class. The init function sets the n variable to the number of tiles in the board. Now that's crazy because it knows that the array represents a board. Of course, that's not kind of crazy because I named it that, but that variable. The init function sets the caption of the screen. Sets the screen size variable to the size of the screen. Yep, because Pygame. The init function sets the variable, sets the tile variable to the board state function. That's not entirely true, but yes. The init function sets the grid variable to an empty list, and then it goes through the list comprehension to insert the tile variable to the tile class, right, at each index in the list, which I think is probably what it would have completed. So yeah, that's really, really freaking cool. That's so. One thing I was about to not explain is I got it to do that in a bulleted list without any specific context, like telling it up in this part of the prompt or over here or anywhere explicitly in the text that it was prompted with, right? And how I managed to get that was that I just told it that whenever you start doing your completion, inject these characters first. And what essentially this is saying is hit enter and then press the number 1 and period. And that kind of creates a structure in the response that we get that creates a numbered list of the things happening in that block of code, right? So like 1, 2, 3, 4, 5, instead of like a paragraph or something, it is a numbered list of the steps of what's happening in this init function. So I just changed it over to the DaVinci Instruct beta and got an even higher quality description. The lights out game class is initialized with the number of squares on the board in. Wow. Pygame init is called to initialize the game. The settings class is created and the screen and width height are set. The game caption is set to lights out. The tile class is created and the board state is set. The grid is created and filled with uh, that list comprehension, yeah. For each square on the board, a tile object is created and the board state is set. The grid is then filled with the grid state. Yep, yep. Wow, it knew all of those grouped classes of things that I didn't even give to this code. That's absolutely insane. This is this is a function that operates the logic in a lights out game where you have to clear all the lights on a board, and it turns all of its neighboring lights back on or off depending on if it's on or off, right? Um, and it's crazy that it knows this stuff. It's not really. I can understand how contextually you get all of that information, but that's just crazy. I'm impressed. Maybe I'm easily impressed, but the the difference in the quality between those two responses is just like I they're both absolutely incredible, but the instruct model is scary. It's dirty. I guess I'll see you guys next time.